Or people who are just stepping into the industry. And most of the time, what happens is like even during your final thesis, you have no idea like how you're gonna go forward. Most of the students का यही perspective होता है, okay, we need to be done with our thesis and get graduated. But during your thesis, I think you can also take these kind of opportunities and also make sure that if you are able to secure one of the project over here, you can just make as a part of your thesis. And not only you can actually work on really good technologies or emerging technologies, but you're gonna also can earn a stipend as well. So it's a really good program, the one which I'm gonna mention, and the way the how I'm gonna be mentioning is, I'm gonna give a use case, and उस use case को ही बताते बताते मैं इस Google Summer of Code का जो program है उसके बारे में भी information बता रहा हूँ. So let's start. If you guys have any question in between, just raise your hand, and I will be happy to answer it. So the whole idea of this presentation is to actually provide a perspectives like how research needs a code and what is the future of open innovation is. And in this case, I'm going to be presenting a use case which I did actually in Google Summer of Code along with Brookhaven National Laboratory. So this laboratory is actually located in New York and USA. And because everything was open source, I had the chance to work with really great mentors and also on the technology that is still emerging as well. So along with that, you're also going to see another well-known name is CERN. So CERN was more of a, I would say, a co-author. I wouldn't say a co-author, but more of a co-partner in this whole project. So let's start with it. So this whole session is going to be divided into 5 parts. I'm going to mention about me. There's going to be an introduction, a use case, Joe I actually developed, more of future outlook of that use case, and what is the open source and open science connection, and you guys can actually ask me questions as well. So a bit of information about me. So as you guys know, my name is Osama Tahir. I'm an engineer. Most of my work is usually connected with hardware and software, and my area of work is mostly semiconductor. Uh, Nowadays, it's also high particle physics as well, and that. And I also usually play games as well. So one of the games that I often like is Dota. Battlefield 6 is like the one which I'm spending a lot of time nowadays at the moment. I mentor meet people a lot, so whenever I get the chance, and if people have any questions, they are often reach out to me on LinkedIn or via my email, and I'm always happy to mentor them as well. Furthermore, I often do arts a lot. यहाँ पर the place where I'm currently living in Netherlands is there's a famous artist. I think most of people might have known about his name is Van Gogh, and I really like his art. So I often, admire him, his art, his work, and the way he actually draw paintings and stuff. I often travel a lot, so most of the time you're gonna see like in one country, maybe in 2 months you're gonna see me in another country. So traveling is just part of my life nowadays. And I often do research a lot. So because I like that area, it's more like a hobby. So whenever I'm not doing my office work, you're gonna find me, working in an area where people often doesn't actually, find it a bit difficult. But for me, it's like finding the right question. So it's more of a curiosity, and the way I usually, spend the trying to find that curiosity is asking by question. If I'm not able to answer it myself, I go and I try to answer like, okay, if this particle is working, like, or maybe let's say if this component is working, how it's working, why it's working. So how, why, and multiple questions. जब आप पूछते हो तो you often have like a mindset of researcher after that. So this is about me, and if I just mention it in a single picture, this is how it looks like. On the left side, you can see a semiconductor machine. Um, on the middle, you can see my university where I got my doctorate. On the right most corner, you can see like traveling. On the leftmost corner, you can see Battlefield, which I often like a lot. In the middle, you can see the painting, and on the rightmost corner, you can see uh, particle collider, which I often, nowadays researching as at the moment. So that was me. And before I move to any news section, do you guys have any questions regarding my experience or the way I have actually, came over here? Okay, I don't see any hands raised, so I will be moving to the next section in this case. Okay, in this part, I'm going to mention about the introduction, about the use case that I did. And the way I'm gonna do it is just by first mentioning about the organization that took part. I already mentioned that before as well. The first one was CERN. These are the people who are actually located in Europe, and they are more related. Their work is more related to nuclear research, and they are actually place where you often see word as Large Hadron Collider. So that word may look fancy, but the main purpose of this collider is to collide particles. And that's something which I'm going to touch a bit later on. The other organization that I mentioned was Brookhaven National Laboratory. This is one of the laboratory that I also mentioned before as well. It's located in New York and it's a part of U.S. Department, one of the U.S. governmental department, and it's Department of Energy. And the third uh, stakeholder was Google Summer of Code. So Google Summer of Code is I'm going to mention like what it does. It's more of a global program that brings contributors to different organization companies who are looking to work on the open source area. So just to give you guys an idea, this program is good, and if you are a student, recent graduate, or even a working professional, I would recommend maybe give it a try this time. This is called Google Summer of Code, and last time I think there were 22,000 contributors from 123 different countries. A lot of code was written, and it's been going for 21 years. You're going to find a lot of mentors as well, and open source organization, maybe like there are thousands. So if you just go to the page, I think I can show you guys really quickly like how it looks like. Percent stop sharing. So window entire screen. Yeah. So this is their page. You just apply, uh, and you just code, and once you code, you share. You're gonna find a lot of things over here in this page. I can share it after the session as well uh, with the people, and you. So yeah, so they have like all the information over here. You just need to go and look upon a bit uh, about this whole Google Summer of Code. But let me give you like more of a high level overview at the moment now. So stop sharing and present this. Yep. So I'm back to this scene. Yeah. So the way it actually work is their application usually opens in January. Like different organizations start applying that time, and if those organizations meet the criteria of Google, they can sponsor their projects, and Google actually pays you a certain stipend to the people who are actually doing that project. So you have an organization at one part, and another part is the person who is actually interested in this program. So you apply via a platform that I showed to you guys, and you find an organization. So this is from a perspective if you are interested to applying to this program. So you find an organization, you engage with the community. So every organization often have their own communities as well. So let's say if you are working on Mozilla Firefox gonna have its own community. If you're looking upon the Google side, they're gonna have their own community. So once you start engaging with it, you're gonna find like for a certain organization there are some mentors as well who actually gonna maybe give you a task, and once you find okay, so this task is given, you do the task, and if they like your work and stuff, they will gonna ask you write a proposal. So you make a proposal, you submit the proposal, And once your proposal get selected, then the mentors will be able to give you mentoring. So for example, if there are maybe 20 projects, there might be like 50 applicants. So it is not really that competitive, but if you are able to make a really good proposal, then you have more chances. And not only the proposals going to actually work, but also like how much you contribute to the code, to their organization or to their code base. And that also plays a really vital role as well on this. And this is how I found my project with Brookhaven National Laboratory and CERN. And that project name was Intelligent Log Analysis for the HSF Conditions Database. So you're going to find the name is like a bit uh, confusing, like, okay, but it does. And this is something which I'm going to reach out to you guys, like what was the whole purpose of this project and how I actually did it. So take it as more of a template. For example, if you guys are interested in applying to Google Summer of Code maybe next year for 2027, you can, take this project as a template. Okay, so Sama actually, gave a session on this. Maybe we can, try it, the whole project, the whole this way, by taking it as a more like framework or a template. So yeah, let's move out later with this project. But let me give you more initiatives that has happened with Google Summer of Code recently. Some of them are like some of the organization you can find is our project. I think most of people who who have worked in the computer science field, they have often find R quite simple. So can anyone let me know how many people have worked on R, or they are still teaching at the university nowadays? Maybe raise your hand. Oh, I see no one is being taught R at the university. That's really surprising. So none of you guys have been taught R, right? Hmm. I don't see any hands over here. Uh, wow, that's really interesting to know. Like you guys haven't been taught R at the universities at the moment now, but at our time, it used to be really fancy language that time. But yeah. Uh, wait. Okay, so let me see if everything is working fine. Okay. So one of the languages is R. And you guys can see, you could see my screen before as well, right? And just send me a message. Anyone can, send in the group. Yeah. So R was one of the project organization you're gonna find there. The other one is Linux Foundation. It's a well-known organization which actually manages Linux and open source innovation worldwide. I think if you guys have worked on Linux, then you would also have known about this organization as well. And they have tons of projects in their portfolio. The other one is PostgreSQL. So this is like one of the database in the companies is really well known and used as well. So this is like they have tons of projects over there as well. And the fourth one is Google DeepMind. I think if you guys are actually uh, a bit knowledge about AI nowadays, then you would have heard about this Google DeepMind company as well. It's like a part of Google, but you can find tons of projects. I think there was one Pakistani guy from Karachi who did apply and was able to get 3 months project with them, and he did it, and he was able to show it to the public. So maybe I can also give his reference later on, maybe at the end of the presentation. So this was all the information related to Google Summer of Code. And now we're going to be moving towards the project that I did while I was working in the part of Google Summer of Code. And my presentation going to start with something called Matter. Uh, so maybe like you guys can unmute yourself and tell like maybe one at a time, how do you guys see matter? So if you see like a word matter, what comes to your mind? Maybe like you can just message in the chat. One word would be fine. So when you hear the word matter, it's related to physics. What's the first thing actually comes into your mind? And whatever comes, then you can just message, yeah, atoms and other things, particle in existence. That's a good start. Anything more? So we have like a lot of people over here, and I see like some uh, more brainstorming, quantum computing. Yeah, that's the whole perspective. And yeah, but whenever I hear matter, there's something that actually comes into my mind. First is the universe. Universe is really big, and you can find a lot of things over here, including us. Substance having mass and space. Yeah, that's also included in that thing. Uh, I think when you talk about energy and mass, you also think about this equation as well. E equals to mc square is one of the uh, equation by Einstein. You also, think about Einstein as well because he has done a lot of effort and work in the field of physics. Um, Another interesting thing that also comes, at least to my mind, is data. So I feel like every matter contains information, and that information is useful. And how it can be useful, we're gonna come a bit later on that part. We think about physics because I think with a lot of information, example that I've showed, physics also touches my mind when I say matter. I also think about magnets as well because even though you like if you have a mirror, then you will have more of a pulling and pushing force as well related to it. You also think about stars as well, because yeah, our sun is a matter one way or another. You think about atoms. I think a lot of people actually mention in the messages that atoms is also one of the things that comes when you think about matter. You think about technology, because a lot of things that I mentioned, especially in the area of physics, that technology also does play a part as well. And you also think about black holes as well, because we are talking about universe, we are talking about stars. So I think it's better to, not leave black hole behind. So this is what I actually, think about matter. And these are the areas where organizations such as CERN, they are playing a really extensive role, and they are working on these areas one way or another, especially the area of physics, data, technology, atoms, and matter itself. So let's see. Like this is what I feel like what CERN does, and CERN and Brookhaven National Laboratory, they have the same aim and objective as well. So they are totally connected with each other. And because I did say atoms as well, so they have different big machines, like the one which you can see is Sphinx PNL is located in this, and they are located there for a reason. I'm gonna come a bit later. So whenever you go to their place, you're gonna find this machine. These are actually large hadron collider, and what they does, I'm gonna come a bit later. There's also a similar machine in CERN as well. Um, and believe me, like if you, just stand there, I think you can see a person standing to this. He just looks small as compared to this. So these machines are really big, and they do something in those machines, which I'm gonna, come a bit later. And those machines are actually located in Switzerland, Japan, and USA. And most of the time they are located in such a way that they are tubes, big tubes like this one, and they are located in circular. Um, and you can find in Switzerland, Japan, and US. And the good thing is Pakistan is also a member of this whole initiative as well. So Pakistan is associate member of CERN. You can actually find in their about me page in CERN. And you can see like Pakistan is also playing a really good role in this whole initiative. But now you guys gonna be thinking, okay, Osama is mentioning a lot of information about these big tubes, circular tubes, but what they do. So the thing is, like in those tubes, what they do is they uh, make sure that like they collide the particles there, and the way they do is like they make the particles go in a really high speed, and when it reaches to a certain speed, they collide at a certain point, and once they collide, they uh, share a lot of information and data, and this is how people in the area of physics are able to understand like what's going on. They are able to find questions related to the universe, maybe how the big bang happened, and all of that information is actually being studied over there. And it just happens because they are these tubes which are actually shown like this one, they are able to do it. So they collide the particles at a really high speed, and those particles are not really big particles. Those are really atomic size particles, and once they collide, they get a lot of information about it. Like they are able to study about new substance. They are able to understand like how the physics actually work in those particles. So a lot of information does come out of that. And as I mentioned, once they collide, they do produce a massive amount of data and logs. And because all of this information is being recorded when those particles hit, that information and log is actually taken as more of a study for different experiments and also for different research groups as well. So a lot of universities in Europe and America as well, and even in Pakistan, they get this data and they try to study and figure out what went. So this is like the whole high level quick overview of what CERN does, what how the Pakistan actually plays in its plays role being a member over there, what the particle collision is, and as I mentioned, it produces large amount of data and logs. So yeah, uh, after giving you guys a really high overview, before I move to our next section, does anyone have any questions? Okay, nice. So everything is fine then. Uh, I don't see any questions. Hmm. Yeah. So I think stop sharing. Am I sharing the correct screen? So every time I go to this main window, I have to reshare my screen. I think it's a problem with my setup at the moment. Yep. So now you guys have some basic understanding what does CERN and DNL does, and now I'm gonna mention like how this use case actually is connected with this whole ecosystem. So I worked upon one of the tool which is called Payload DB, and the whole purpose of this tool was to provide metadata for different experiments. So when you are running, let's say, an experiment, and when I say experiment, it means like there might be a task or maybe like a process where they collided the particle, and now they have to study about like how what type of information is being produced and stuff. So in one of those experiment, if you need like a certain configuration for that experiment, कि मैं ये चाहता हूँ कि इस experiment में जब ये particles collide कर रहे हो तो ये इस speed से collide कर रहे हो, maybe इतने बड़े particles हो. So just for all of those information related to that experiment, they have their own database for that. And this Nobel DB, if you're gonna give certain name about that experiment and some information, it's gonna give you a whole metadata, and you can actually access the experiment conditions once the experiment is done. and you can actually study like what type of data it is produced, what were the things and information. So it produces like more of a record once the experiment is done, and you can study those record on the basis of what type of information you provide as when you're accessing the data. So I worked on this no payload TP, and it's designed according to reference architecture. And the way I actually mentioned is, you it's a more of an architecture where you can more of a system where you can actually refer, and it's going to give you, once you refer, you can get a specific amount of information. In this case, is like the output of an experiment. If you give like certain parameters, it can you can actually get a certain amount of information. And this is how most of the reference architecture usually works. And they are built in such a way that you can actually scale and also make sure that scale for different experiments depending upon your requirements. And this reference architecture is actually deployed on OpenShift. So OpenShift is similar to Kubernetes. So if most of you people have worked on Kubernetes, OpenShift is much secure. It can actually handle a lot of requests and also workloads as well. So once, let's say, an experiment happens, and just to like for other teams to get information, there are maybe like 1,000 or 10,000 requests coming at the same time, because it's a really big organization, and whenever an experiment happens, and if everyone wants a pie out of that experiment, it means like everyone wants the information of that experiment. So you will be having a lot of requests at the same time, and because the number of requests are increasing, you also need to make sure that your system is also able to scale accordingly as well. And as I mentioned, like the picture that I showed for the big tubes, this no payload DB is actually being used in those experiments to help the researchers and the people who are working in those areas. So, but they had a problem, and now you guys gonna be thinking, okay, the tool seems well, or everything was going fine. So what's the problem in it? So the problem was this database actually lacked a centralized logging system. So anyone who was able to access it, let's say maybe 5 or 10 different research groups, they are able to access it. Um, it actually lacked a centralized logging system. So maybe like for 2 or 3 experiments, if this tool is working, uh, for one experiment, they might be able to get the logs, but let's say if another experiment is happening in different part, because it's a really big tube and there are different experiments happening in different location, they are not able to get a centralized log. So if 5 or 6 experiment happening in a specific location, let's say maybe in Switzerland, or one is happening in Switzerland, the other one is happening in USA, they needed like a system that can actually get all the logs and the research information in one centralized area. So no payload DB didn't have that, and this actually created a lot of issues for them of tracking. Like, okay, ये system चल रहा था और चलते चलते खराब हो गया. अब what they have to do, they have to go through all the logs, and those logs are coming actually from 6 different experiments. They have to access that experiment to understand like what actually went wrong. So it lacked a centralized logging system. Logs were unstructured because when this tool starts working, it's like a Django-based tool. Those logs uh, produced by the app, they were unstructured and hard to analyze because, yeah, like different experiments are happening, and this tool is also working on that area. So those are unstructured. That was one of the issue. And if you want to, understand like, okay, what went wrong, you have to spend like 12 hours sometimes. And it takes a lot of time consumption, especially, when you already had a large, uh, when you already had a physics experiment, which took maybe like 2 days to, just set up and also initiate and everything. And once it's completed, you have to wait now 12 hours to manually assess, like if something went wrong, then what went wrong. So it's a really high labor. So that was one of the issue as well. And because you are actually working and trying to go through every single log, there isn't any reliable way of detecting the error, because we are all human. We do sometimes make mistakes as well. So detecting error is wasn't easy on this way of doing it. Then what we came across with a solution, and we named it as intelligent log analysis for the conditions database. And what this project did, it provided a centralized automated pipeline. So every problem that you saw in the previous slide, we created a solution just to make this tool better. We because I was working on this and along with my mentors, we use open source tools to make sure that the logs that are coming are scalable. Like the system can actually be scalable. It can ingest the logs, provide a certain amount of storage, and also provide real-time visualization as well. So this is what one of the things we did. We use open source tools, as I mentioned, for other things as well. Um, we made sure that all the logs that are coming are structurally parsed, and we also added AI-based anomaly detection to detect the logs as well. Like if there is an anomaly within a log, then it can be detected. So we added that part as well. And this not only like once we had all this done, it did not only like improve the system reliability, it also improved early detection of the errors. And because everything was now automated, it made sure that everything was now more, it also made sure that everything was more operationally efficient. So these were the areas that we worked, we got a solution, and the system was actually tested in different experiments that I will gonna come a bit later. I know you're going to be thinking, Osama, on so you have got a problem, you did make a solution, but how do you implement it? And that's the fun part. And I think everyone who are uh, in this whole session are mostly, I think, in the area of computer science and engineering. You often find implementation to be most exciting part. So what we did, we divided this pipeline that we made into three parts. One was the process. The main purpose of the process was to collect the logs and ingest. The second part was to monitor, because the logs were collected and ingested. We needed to make sure that the logs are being landed somewhere. So we made a storage that can actually scale accordingly. And once the logs are stored, we were able to provide visualization via Grafana and also monitor them for anomalies and stuff. And as I mentioned, we did provided like AI anomaly detection. The third part was to predict. So logs were parsed before they actually come to this point, and those were not only parsed but were parsed in such a way that we could also detect anomalies out of it. And we use certain number of tools over here. So I think if you guys are from computer science field, like I think most of the audience are, you might have actually heard or at least work on a few of these technology. So maybe like from the audience, if you guys have worked on these technology that I have mentioned, just mention their name on the chat, and I would love to see like maybe if you guys have worked, then I can also help you guys or maybe support you how you can use these technology in other parts as well. So a single message in the chat I think would do. So anyone who has worked on Redis can mention Redis on the chat. If anyone has worked on Grafana, oh, okay, nice. Hamad has worked on Grafana. That's good to know. Uh, anyone else? So I think only Hamad message. Yes, Docker. Nice to hear, Aisha. So you have worked with Docker, and I think you have worked for containerization and stuff, right? Nice. Anyone else? Kafka. That's good. Mohammed Junaid has used Kafka as well. Yeah. So it's good to know, like, because I think when I was doing my bachelor's way back, in 2013 to 2017. We were introduced to these technologies that time. हमें खुद पढ़ना पड़ा था. Professors, they didn't taught us, so we had to make sure that we had to go like through multiple sessions, YouTube videos, just to understand what this does. But yeah, if you guys know on being a student, then I think it's really good. So this was the implementation part, and in the end, what were the results? So currently, this pipeline is being tested at CERN. So if anyone can, Google CERN, they would be seeing like it's a really big experiment, big organization, and they have multiple experiments running. And what actually it provided in the end, that it provided real-time anomaly detection. It was highly scalable and available as well. And it was also able to improve monitoring as well, because most of the things, as I already mentioned, was automated. So most of the technology that you have seen are, you would have noticed, like most of them are open source, and you can just take out and maybe add another alternative. So it's more of a modular as well. So that's the way we actually made this. So once we actually were done with this whole uh, project, there were a few things that I actually learned. And maybe if you guys are planning to apply for GSoC in 2027, you can just note down these lessons and study that I learned from GSoC. So the first thing, which was like, whenever you are making tools that are open source, you're gonna find a lot of alternatives. So if you have a project and they have told you, you need to use certain tool, maybe Redis. For Redis, you might actually find another tool that might be helpful. And if you're developing a tool, also make sure that maybe focus on the long-term growth, because these tools going to be used by like millions of people sometimes. And if you are making such a way that it can actually help the whole community in the future as well, then I think it's the best approach. The other thing which I actually did was research and learn. So as I mentioned, I'm a researcher. I like doing research as a hobby, and it was also able to help me learn a few things as well. So that's one thing. And whatever I learned in research, I documented everything up. So I think it's better if you learn something and you document it. It doesn't only store it like temporarily, it stores information in your mind like permanently. So that's one of a way of doing this GSoC. And if you are able to question like everything, like the way I do, the why, how, like the why, how, when, and stuff, um, I think being a curious makes you more of a like motivated to learn more. So try to take that approach and be consistent. This is something which I often find really difficult to maintain, and for a lot of people I know it's hard to keep as well, is the consistency. So if you're able to learn, be consistent, you can actually um try to, you can actually achieve a lot of things. So these were a few things and most of the lessons over here. So before I move to next section, any questions? Okay, so I don't see any question. uh okay, I have to window. Yep. Yep. So future outlook, how everything ends up for these projects in the end and for the future. So there is some further research required, because the way we actually made the anomaly detection part was by using deep and machine learning models. Uh, so if other models are used, I think the one which we used was deep lock. um, there is an option to use other models as well, because we have made it such a way that you can just take it out and use another one. Other more information can be gathered, like how it's actually working while it's actually detecting the anomaly. Um, this project does need further support from the community. We are trying to introduce this to different organizations, first of all within CERN and also beyond CERN as well, because this pipeline is, you can just use this pipeline for any other software as well. And it can not only, make the anomaly detection automated, but also make sure that your tool is working more efficiently as well. So this whole pipeline can be taken out from this project and can use other parts as well. So yeah, we are trying to promote this to different organizations within CERN and outside CERN as well. Uh, so right now it was only tested for one experiment. Now we are testing for other experiments as well. So one of the experiment was Sphinx, as far as I remember. But for other experiments, we are trying to integrate and trying to see like what type of response or results are getting. So far, it's going well, especially with the one where we have added this tool. So it's working properly there. And yeah, so right now it's just deployed to CERN cluster, because these experiments, when they run, they have like their relevant tools and stuff, and those tools usually work within a cluster environment. So right now, and every organization does have their own clusters. So right now we only have deployed on CERN cluster, but it also needs to be moved to BNL, because BNL has their own experiments running in US. So that's going to be done in future. Yeah, so this was the future outlook, and now everything comes into the last part of this session. That's the you guys going to be thinking, okay, Osama had given a really big session, but we didn't had the opportunity to see the open source and open science connection over here. So when you see open source, I think for most of people, at least for me, open source is more of a development model that provides a free access to the source code. It can actually also allow users or anyone who's interested to using that tool to not only use but modify and distribute software freely. One of the example which I gave was Mozilla Firefox. It was open source, and a lot of other tools that you guys often use are open source. One of the language that I gave example was R. R is widely used within different experiments, within different scientific research. So it does play a lot of roles, especially for studying about the data. So open source has its place, especially within scientific community. And when I say open science, so open science, if I just go with the definition, it's more of an open movement to make scientific research data, to make the research data and results accessible to everyone, from professional researcher to the public. So the way I gave you guys the example of the project, now you can actually start connecting uh, ticks or boxes and stuff, and you will be thinking, okay, so this guy, so this project was scientific based. uh, I It was a movement to make sure that everything which we were doing is publicly available, especially the results, the data. So people who are interested in this area, they can also further research that how log analysis is happening. And there are a lot of great researchers which I know, they are working on this area. And you also would have connected that the tools that I used, which I did ask during the presentation, were open source as well. So now you're going to find a connection that open source and open science, especially the time where we are living right now, where everything is restricted, uh, is playing a lot of role, especially in advancement of different research, whether it's happening in Pakistan, whether it's happening in Netherlands, whether it's happening in US. So both of them, even though they have different domains, they are connected a lot. And if you go to any university like MIT, Stanford, most of the tools that they work on, they are sometimes open source as well. So other can contribute, other can make the tooling better. And because the way they usually do research is they have a problem use case. That use case might be related to that domain, but later on, and if they have developed a tool for that use case, that tool may be not only used for that domain, it can be used for different domains as well. And right now, I don't have any example, but if you just sort of Google it and research a bit, you can find a lot of connections there. Uh, yeah. And there's one saying over here that open science without open source is incomplete, and without both, there is no open innovation. Because when you are doing innovation, the way I see innovation is like everyone needs to be involved, and involved in such a way like everyone brings their own ideas, their own perspective, and this is something when like a single mind, a lot of minds are better than a single mind. So if you have ideas flowing from different perspective, from different region and stuff, then I think that's the place where we start, innovating stuff. And that's why we have so much amazing things, especially in the area of semiconductors, especially in the area of physics, because a lot of people from different regions, from different part of the world, they are sitting in a room trying to understand, okay, we have a problem, we have to understand. And open science and open source actually, provide this accessibility digitally. So anyone who doesn't have maybe sitting somewhere in the corner of the world, they can join not only like via call, but also like via open source and via open science as well. The way I have given example. And there is one saying from the creator of Linux and Git, Linus Torvalds. I often compare open source to science. Science took this whole notion of developing ideas in the one and improving on others people's ideas. It made science what it's today and made the incredible advances that we had possible. Same thing that I mentioned, that uh, it's perspectives coming from different regions, from different people, and trying to merge together to create something beautiful. Yes, and this ends my whole presentation in the end. And I would love to know if you guys have any questions about this.
Thank you so much, sir. This was really a fascinating session. And I think many of us now have a better understanding that how research and technology can complement each other. And
Mhm.
now, as you said, we'll move towards the Q&A session. If any of you are having any questions, feel free to drop them in the chat or just open your mic and go ahead.
Yeah, so while everyone are trying to come with a question, I see some ring there. Okay. Is there a hand
Sir,
up? Yeah.
sir, Assalamu alaikum.
Why, Islam?
सर माय क्वेश्चन इज कि अगर हम खुद का ही ओपन सोर्स एक प्रोजेक्ट लॉन्च करें और उसमें
Mm-hmm.
कंट्रीब्यूट करें तो
Mm-hmm.
हम एज अ ये फ्लेक्स कर सकते हैं कि हमने ओपन सोर्स किया है.
इसको इस तरीके से देखो, अगर आप खुद का ही ओपन सोर्स प्रोजेक्ट इनिशिएट करते हो और दूसरे इनवाइट नहीं होते, तो वो आपका खाली पर्सनल प्रोजेक्ट होगा. Open source project is more of community driven project. It can be a specific use case, or maybe a common tool where everyone use. And I think a lot of people actually does it make it such a way that others can also be invited. So अगर आप खुद अपना प्रोजेक्ट स्टार्ट करते हो और खुद ही कंट्रीब्यूटिंग कर रहे हो, तो वो आपका एक्चुअली पर्सनल प्रोजेक्ट है, राइट. एंड जो open source है, open source is actually meant uh, for other people to be invited, and also not only like your own community but other people from other communities as well, and that's the whole purpose of open source.
थैंक यू सर.
Okay, so I see a question on chat. In the picture you showed previously, Are these two different colliders or a single tube running from Switzerland to the US? These are two different colliders. One is located in CERN, that is in Switzerland, Geneva. It's also, part of France border as well. And the other one, which I showed, was located in US, and that one was in BNL. So CERN and BNL, these are two different entities, and they often work closely with each other. CERN is more uh, usually does the experiment research that are more reference to European, and the BNL ones are usually more interconnected with US. So the two pictures that I showed, you can actually also find on the internet as well. These are two different tubes looking at two different places. Any more question regarding Google Summer of Code? Yeah. Yeah. So, any more question regarding Google Summer of Code, or maybe let's say open source, or maybe how do I actually start working in open source environment? And I think most of you guys, if you are a university student and working in your thesis, this opportunity can be a really good way of ending up your degree. Because I think if you are choosing your own, I think in most cases, जो students हैं वो अपने ही thesis they come up with. But if you have come up with this 3 months project to your university, I think most of the university not only actually support but also the professors, they also tend to help a lot. And I think in a lot of universities, especially in India, they have started doing this way of working. But I think there's also a good opportunity for university in Pakistan as well. Okay, so before I end,
So,
yeah,
सर एनी कम्युनिटी जो ओपन सोर्स में मतलब काम कर रही हो पाकिस्तान में टॉप लेवल पे
Pakistan many I couldn't actually find within Pakistan, but if you just go to this website, let me share my window, full screen, uh, and you can see browse all organization. This is the same website that I showed. इसमें आप देख सकते हो कि कौन कौन सी organizations हैं. You can see video line. I think if you guys have downloaded this. This is a really common tool. You can see Unicraft, R, the one which I mentioned, the Git, if you have used GitHub. And I think if you just search it, let's say if I search Google, you can see Gemini CLI. It's one of the tool Dart. So yeah, there are a couple of company organizations there, and each organization has their own ideas which you can actually take part of. So these are like one. If I show you, let's take not still live, but Kush is. I think let's go for that. If you go over here and view project, you can see like all the list of proposals which you have. और उसमें आप every organization have their own proposals, own projects where you can actually create a proposal, and before you can send a proposal, the mentors in this project, I think it's Message and Tatiana. uh, they give you a task. If the task is performed well and you also have contributed to their open source repo or maybe their community, and they like the task, they will tell you like to create a proposal. And you can find a couple of videos or tons of videos how to create a proposal for Google Summer of Code. And once you have created a proposal, you submit it, and submission के बाद फिर आप project start कर लेते हो. It has to like the first time they pay is like in the middle of the project. I think if you guys are working for Pakistan, they pay around like $3,000. And the second pay, a second stipend जो आपको मिलता है जो half, वो आपको फिर project के end में मिलता है. So it's 1,500 and then another 1,500. So yeah, there aren't any organization in Pakistan, but outside Pakistan there are a lot. And while being in Pakistan, I think you can just apply. Any more questions? Okay. How can student in Pakistan build a profile that is competitive for opportunities like GSoC, CERN, or international internships? That's a really good question. So how you can create a profile? जो स्टूडेंट्स हैं मैं उनको यही हमेशा कहता हूँ जब आप यूनिवर्सिटी में हो टेक लाइक फुल एडवांटेज ऑफ बीइंग इन यूनिवर्सिटी एंड दैट्स अ प्लेस वेयर you can not only do research but also collaborate with others other universities as well. So if you are in Pakistan and you are working or building a profile and you start from university, start with research first. अगर आपका कोई प्रोफेसर जो let's say NLP के एरिया में काम कर रहा है, try to engage with him, try to write research paper, try to publish in good journals. I think मैं वो चीज़ बता रहा हूँ जो मैं खुद नहीं कर सका यूनिवर्सिटी में that time because I didn't know, no one guided me. But if you guys are here, I'm guiding you in that case. So try to create a research profile. Make sure that you know what you are doing. दो चीजें होती हैं. I think most of people they often think about the GPA. Don't think about GPA. I think once you graduate, no one often asks you. They often ask you like आपके portfolio में क्या है. So research projects, research is like good. The other thing is you can just go to any depot and start contributing, and it's not that difficult. Maybe I can actually show you this one organization which I have been a part as well. Entire screen. So if you go, maybe there is Qflow. Yeah, GitHub. So this is like one of the open source projects, and you can actually find Qflow pipelines. I think Spark Operator is one. So you find the organization. Main example is कि Qflow की दे दी. I think you can also find it over here as well. Yeah, Qflow. It's a machine learning toolkit for Kubernetes, and this is their one of the tool. And I think if the project is about this tool, then you can just go to the issues. Beginners के लिए आप ये कर सकते हो कि label ढूंढ सकते हो जिसमें most of the time इसमें लिखा होता है first good first issues. Sometimes available होते हैं, sometimes नहीं होते हैं. अब जैसे ये है Spark Operator roadmap. um, like ये एक issue है, but you can find tons of them. And I'm just giving you one example, but you can actually, while exploring, you can actually see. You can find an issue, start working on that issue, create a pull request, merge that pull request, and this is how you start creating your profile, especially in open source area. और जब companies or maintainers जो इस open source tool को देख रहे हैं and they see okay you have contributed a lot, then this is how you get opportunities in different organization. Because if you are good, let's say a code maintainer or let's say a contributor, these things they don't go away. They do stay online. Like you can just show it in your GitHub as well. And if you're a computer science student, most of the student which I have seen is like they start creating their portfolio, a website, fancy website, उसमें project डाल देते हैं. But जब वो graduate होते हैं उनके पास like other than showing their website and some projects at the university which they did as a part of this semester, they have nothing. So in that case, I always mention like make a really good GitHub, do open source contribution, whatever projects you do, which had like an impact, put it in your GitHub. At least you can actually show to different audience and stuff. Or I think recently I was going through LinkedIn. Some of the students in Pakistan, at least they have started doing this in such a way that I think Ashkal, especially is monsoon season, you have a lot of floods in Pakistan in different parts. So they have created like a project as a part of their final thesis. जिसमें वो they were able to figure out like if this flood is coming or not. So that kind of project has a lot of impact, not only Pakistan but outside of Pakistan as well, because you had a problem, and that problem had a lot of impact around or could affect a lot of people, and you created up with something that could actually help. Uh, don't think like okay मैंने thesis की तरह इसको throw away करें. that project actually can take you places. So yeah, I hope I have answered your question well. Okay, any more questions? हाँ, और एक और चीज मैं बताना भूल गया, बिकॉज अ लॉट ऑफ स्टूडेंट्स, मैंने एक चीज और नोट की है, try to reach out to your network. So if you see, let's say, a senior, if मैंने खुद एयर यूनिवर्सिटी से बैचलर्स किया हुआ, and I see a junior who was studying from a university trying to reach out to me, I'm always going to help. So most of the seniors, they always have that perspective or mindset to help their juniors and stuff. So try to reach out to your mentors, your seniors. उनसे मैसेज करो, उनसे पूछो कि कौन कौन से प्रोजेक्ट किए जा रहे हैं, क्या इंडस्ट्री में आजकल स्टैंडर्ड है, बिकॉज द यूनिवर्सिटी, whatever they're going to be teaching you, it's going to be outdated one way or another. So if you have like the most updated information from your senior, uh, in that case, it can actually help you to land a job. Sometimes not all inside Pakistan, but also like most chances like outside Pakistan, आपको help both, not only outside Pakistan but remotely help कर सकता है कि बहुत सारी companies remotely काम provide करती हैं. Then you can also get opportunities out of that as well. So don't be just restricted to the university. Go beyond the university. Um, okay. Which emerging research in do you think students should pay attention to? There isn't any single field, क्योंकि अगर मैं एक चीज बताऊंगा तो most probably I think 2 साल के बाद वो no one's going to be pretty interested in, और इसकी वजह ये मैं बता सकता हूँ. I think when I started my bachelor's, everyone were going for cloud computing. I think every single guy who I used to talk, he used to say about uh, cloud computing. उसके बाद फिर once I graduated, people started talking about blockchain, and it went for a couple of years. And now was blockchain, then NFT games, and now is AI. So a lot of people are talking about AI, and once that curiosity gets finished, then it can be any other single technology. It can be maybe quantum technology. A lot of people are doing research in that. It can be maybe technology related to drone or maybe space. So no one knows. It depends like how the world is going and what if I say in a higher perspective, it depends uh what what is interested to the people. If people in a lot of community members, a lot of people find interest in quantum technology, everyone in starting from the top management till the student, everyone gonna start talking about it. So there isn't one answer. I would say like just keep yourself updated on LinkedIn or maybe like online platforms. Talk to people, because once you don't talk, once if you don't talk to the people, you won't know like what's happening in the ecosystem. So I think it's best. I can't say which technology you can actually put more focus. Uh, I think the best way to answer is like keep yourself updated. I hope I am able to answer that question.
Thank you so much, sir, once again, for such an inspiring session. And we all genuinely enjoyed listening to your journey and your perspective on how research, coding, and open source innovation can create a meaningful impact. And I'm sure everyone here is leaving with some new ideas and plenty of motivation. And
Nice.
thank you to everyone who joined us today. Yes, sir.
Yeah. So if anyone of you feel like okay, I have more questions and stuff, just send me a LinkedIn request if you are not connected and send me a message. You can reach out to me on that. The screen. Maybe you can just use the QR code or maybe use the username. So if you have any questions, concern, and you need like some clarity in your career, just reach out to me. I can help. And the main motivation, at least for me, ये है कि जब मैं I think bachelor's कर रहा था, I couldn't find a mentor, I couldn't find a person who can actually guide me. But at least like उस चीज को overcome करने के लिए मैं खुद लोगों को अब mentorship, guidance वगैरह देता रहता हूँ online. And that's all from my side.
Yes, exactly. That's what we actually learned from our experiences.
Mm.
Okay, before we wrap up, don't forget to follow us on Instagram at the rate IEEE.zu and connect with us on LinkedIn to stay updated on our upcoming events. Until next time, keep learning, keep exploring, and don't be afraid to step outside your comfort zone. Everybody, Allah Hafiz.